Welcome to CPFD's Getting Started with Barracuda Virtual Reactor 22.0 webinar. We're excited to have the opportunity to tell you about the 22 release and show you a number of new features and enhancements. This webinar is being recorded, so if you miss anything or want to share something you saw with a colleague or friend, you'll be able to do that. The recording will be posted up on our webinars and presentations page under the resources tab. This webinar should be posted there within the next 48 hours, so make sure to check back and you can view the recording at that time. We would like this webinar to be interactive, and we need your help to make that happen. As you think of questions, please put them into the question panel. We have intentionally allocated a significant amount of time to address questions after the presentation. It will help us stay organized if you put in the questions as they come up instead of all at the end. For those of you joining us today who are new to CPFD Software, let me briefly introduce our company. Here at CPFD, we are advancing multi-phase simulation and technology for fluid particle systems, primarily fluidized bed reactors. Our Barracuda Virtual Reactor software product makes the 3D transient hydrodynamics, heat balance, and chemical reactions in industrial units possible to model. This is typically used to improve the reliability and performance of these systems through simulation. These are often industrial units that operate 24/7 for quite possibly years on end. For operating units, virtual reactor simulations allow you to look inside the system in a unique way to determine root causes of underperformance and use virtual testing to reduce the risk of making any changes. And often as you're looking at the software results, other ideas come to mind and additional optimization opportunities are identified. For those of you developing new technology, Barracuda is used to accelerate and broaden the R&D process and then quickly commercialize, scale up, and communicate the unique capabilities of your technology to customers, partners, and others. Okay, now let's get into the webinar itself. Our presenter today is Rosemary Clark. Rosemary is a chemical engineer who's been with CPFD for 7 years, and her current role is a senior support engineer. If you've attended a Barracuda training class or emailed us for support, there's a good chance that you know Rosemary. She also works with CPFD's development team as a writer for the user manual and is CPFD's primary CAD designer for service project work. Rosemary, I'll hand it over to you now so you can tell us about the Barracuda 22 release.
Okay, thanks for the introduction, Sam. And thanks to everyone who's joining us for the webinar today. The development team here at CPFD was hard at work on Barracuda version 22 this spring, and I'm excited to highlight the new features and enhancements in this release. If you're a Barracuda user, you should have received your release email in mid-May, and if you didn't, please let us know and we'll make sure that you're on our email list for release announcements. Version 22 is available for download on the CPFD support site. So if you haven't gotten it yet, I encourage you to log into the support site to download it. You can find more details about all the things we'll cover today in the release guide chapter of the user manual, along with links to the full documentation sections in the manual. This year, one of our main goals is to expand Barracuda Virtual Reactor's multi-phase simulation capabilities for vapor, liquid, solid, or VLS systems. And several features in the 22 release are exciting building blocks in this area. To set the stage for the addition of three-phase system modeling in Virtual Reactor, we began by bringing the Evaporation Model out of beta and adding a new phase of liquid/vapor. The new phase allows for realistic modeling of evaporation between the phases as it simulates mass transfer between liquids on particles and corresponding vapor phase materials, and it takes into account the heat of vaporization. This animation shows the evaporation model being used in an FCC riser simulation, demonstrating how engineers will now be able to model complex multi-phase systems more realistically than previously possible. This simulation is included in the Barracuda training directory as an optional exercise, and we have updated it to utilize the new evaporation capabilities in 22. The oil droplets are being injected as a liquid, and then they evaporate into the vapor phase where the material can participate in further chemical reactions. To show how the Barracuda GUI has been updated to support the new liquid/vapor phase and also highlight a number of other improvements, I'm going to exit the presentation now and bring up the virtual reactor interface. So there's been quite a few GUI improvements in version 22. The first one I'll show is in the Grid Controls tab of the Setup Grid window. We've added a generated grid info section to the far right, which shows information that was previously only available in grid.log. Having this information easy to see in the GUI should help to make the gridding process more efficient. Once the grid has been generated, the following information will be displayed. First, the number of real cells in the generated grid. Real cells are inside the domain of grid and CAD, as opposed to null cells, which are cells that lie outside of the CAD model. And no computations are performed in the null cells. Next, you'll see the total number of real and null cells in the generated grid. If this number is not equivalent to the total cells value in the grid line section, the generated grid is out of sync with the grid line definitions in the GUI, and the grid generator must be run again in order to update the generated grid. And finally, the date and time at which the grid was last generated will be shown. This can be quite helpful when working on meshing to determine if the grid has been generated recently enough to incorporate all of your changes. The next area of the GUI I'd like to highlight is the base materials editor. So let's take a look at the gas oil material. For a given liquid/vapor material, the liquid and vapor phases have the same name and are distinguished by either an L or V indicators throughout the GUI. The base materials editor was redesigned to use tabs for better organization. The liquid phase is unchanged from previous releases, and vapor phase materials are modeled in a similar manner to gas phase materials for the purpose of physics calculations, but are associated with their corresponding liquid phase in order to model evaporation and condensation. The evaporation model is enabled through the base materials editor of a liquid/vapor phase material, and the user specified parameters for the model include the vapor pressure and the vapor mass diffusivity. If the liquid surface vapor pressure is greater than the surrounding vapor partial pressure, evaporation occurs. And conversely, if the surface vapor pressure is smaller than the surrounding vapor partial pressure, condensation occurs. And since evaporation and condensation are the same physical phenomenon in opposite directions, evaporation is the only term used in virtual reactor. And the heat of vaporization can be specified by the user in several ways, depending on the information known about the liquid and vapor phases. So I'll exit the base materials editor now and move to the data output section of the GUI. The data output section has continued to be made more consistent and easy to use with the addition of pick lists and visualization data and average data. New output variables have been added as well to improve post-processing capabilities. New output variables include cell ID, clouds per cell, and particle volume fraction by species. Some variable names in TechPlot were also changed for clarity. And although this will mean changing variable names in any PyTechPlot scripts you might have, there is an easy workaround available for that. And let us know if this is something you've run into, and we can quickly get your scripts working again. So let's take a look at some of the results of the FCC riser training problem by opening the latest visualization file in TechPlot. This opens up a particle view where the particles are colored by particle volume fraction. By double-clicking on the contour legend, I can change the particles to be colored by cell ID. And then I can add a slice of cells colored also by cell ID. I have to go into that contour legend and change that to cell ID as well. Yeah. So this shows corresponding information verifying that the particles are individually identified with the cell in which they are currently located. And now I'll turn off the scatter layer and color the slice by clouds per cell. This is useful to see how the particle resolution is distributed spatially. Generally, you want to see values of 20 or higher in regions where particles are present. And next, I'll color the slice with volume fraction by species. And if we look at species 1 first, which is the catalyst particles, we can see the contribution to volume fraction by just that species. And if we color by species 2, which is the oil droplets, we can see a much smaller value contributing near the injection locations. And this is a data output variable requested by a number of users and should be very helpful for simulations that have multiple species mixed together. So next, let's look at mole fraction of gas oil in the vapor phase. This shows that evaporation is occurring and where the gas oil vapor is being produced. You'll also notice that the variable name is quite descriptive, and this is one of the variable name changes compared to previous releases. Our goal is to make the contour legend label and the output file headers as clear and consistent as possible. And one other change to variable names that I would like to point out is for time average data. I'll color the slice by time average fluid temperature. And the variable name is now more descriptive than what was used in the past with no abbreviations so that it's easier to read. And that's all I want to show in TechPlot. So let's get back to the Barracuda GUI. One other post-processing related change that I want to point out is related to FluxPlane files that contain fluid species information. With the addition of vapor phase and liquid improvements, we've changed the file name suffix from gas SPC to fluid species in order to more generically name the file and then make it more readable. This flux file is only created if a fluid species behavior is selected in the FluxPlane options section, such as in this pressure BC in the riser example. And now, to elaborate on a few more liquid phase improvements, I'm going to return to the presentation at this time. Okay. All right, and we've made a number of other significant improvements for simulating liquid phase materials. And again, this is working towards simulating the VLS systems. This animation shows a simulation of an ebulated bed, which is a liquid domain system with particles and discrete gas bubbles. And we're working on a full release of gas bubbles for 22.1, so this is just a sneak peek of what will be available in the next few months. But the new liquid phase improvements in the 22 release include the following. First, multiple liquid materials can be present in the domain for incompressible simulations. This expanded capability enables more sophisticated and realistic simulations of liquid domain systems, especially when used in conjunction with liquid phase chemical reactions. In liquid domain simulations, multiple liquid materials within the domain can react with each other, and liquid materials in the domain can react with particles as well. And both volume average and discrete particle chemistry are supported with this. Secondly, in gas and vapor domain simulations, liquid components of particles can now participate in chemical reactions. And both volume average and discrete particle chemistry are supported, and the liquid components of particles can participate in chemistry in the same way solid components of particles are treated. And finally, liquid mass transfer is enabled for particle collision in gas and vapor domain systems. So the transferred liquid material coats solid particles as a film or adds liquid mass to pure liquid particles. Baffles have also been updated in this release to allow filtering of particles based on particle flow direction. This particle filtering for Baffles adds a great deal of versatility to the modeling of particle and fluid distribution devices in Virtual Reactor. A directional particle filtering section has been added to the baffle properties dialog, and the positive direction vector for the filter, along with the velocity vector of the particle as it passes through the filter, will determine if the positive or negative pass-through probability is used, and this allows for precise filtering of particles through the filter. And in this animation, a baffle is shown at the bottom of the vessel with discrete gas bubbles being introduced below it. And the bubbles are allowed to pass through the distributor in the positive Z direction, but not in the negative Z direction. So this feature is another building block in the process toward modeling VLS systems, and should also be useful to people simulating distributor plates in gas solid fluidized beds. And again, just to remind you, the discrete gas bubbles are planned for the 22.1 release, which is coming in the next few months. We've also continued to add new post-processing scripts to help streamline data analysis. The script Flux to PSD, which is included with version 22, is based on the older Flux to PSD.tcl script, but offers more cross-platform support. It calculates the PSD of particles crossing flux planes, both internally and at boundary conditions, with the bin by particle size flux plane option. The support site post listed here shows example of the script being used to calculate PSD at a flux plane over all simulation time, over a specified period of time, as well as calculating the cumulative PSD of all species at the flux plane. And here at CPFD, we're dedicated to a pleasant user experience that allows for quick and accurate modeling of your particle and fluid system. So users of Virtual Reactor 22 can expect simulation speeds equivalent to Virtual Reactor version 21.1. The 22 release includes all of the new modeling capabilities and physics improvements we've discussed so far in this webinar, while maintaining solver performance and scaling of simulation speed versus number of GPUs. So the plot on this slide shows GPU scaling benchmark results for several large simulations. For simulations with less than 10 million clouds, we recommend using a maximum of 2 GPUs. But for simulations with higher cloud counts, using up to 4 GPUs may give significant additional speed up. If you'd like to try out the multi-GPU simulation capabilities of Virtual Reactor, you can perform timing tests on your own simulations using test drive mode, which runs the solver and records simulation speed information. And if you wish to perform timing tests using multiple GPUs, you must have multiple GPUs first installed in your system that meet our multi-GPU system requirements. And if you're currently running Barracuda in single GPU mode and want to gain the benefits of the multi-GPU speed improvements shown on the previous slide, we want to make sure you're aware of a few license-related items. Multi-GPU simulations are only supported on Linux systems, so just please keep that in mind. And if you already have multiple GPU licenses and you have a Linux system with 2 or more GPU cards, you have the ability to use multi-GPU. One GPU license token is checked out for each GPU card used to run a simulation. So if you would like to add GPU license tokens to your RLM server in order to support multi-GPU simulations, you can contact our sales team. It is possible to add GPU tokens midterm, and we can work with you to make sure that those licenses you have are meeting your needs as efficiently as possible. And just remember, if you attended our users conference in Chicago in June, you received a certificate for 500 hours of metered licensing. And this can be used in conjunction with your current license to explore multi-GPU usage. And so please contact us soon about using those hours, since they do expire at the end of September. And if you have questions about hardware, please contact our support team, and we'll be happy to help you select the best GPU cards for your situation and budget. We partner with a number of companies such as NVIDIA and Mark III Systems, And in case you missed our joint webinar about the DGX Station A100 system, I encourage you to check that out on our website's resources section. Finally, keep in mind that RLM Cloud licenses make it easy to use either on-premise hardware, cloud computing resources, or a combination of the two. Talk to us about your specific needs if you're interested in any of these options. And now I want to pass it back to you, Sam, to prepare for any of the questions that might have come in during the webinar.
Okay, thank you, Rosemary. We'll be getting to those questions shortly, so if anyone has more questions, please make sure to put those into the questions panel. For anyone who's new to CPFD software, I want to briefly let you know a few different ways that you can get started working together with us. Software licensing is the first method, where your team uses Barracuda directly to set up, run, and post-process simulations. We have a number of different licensing options available, so please contact our sales team for specifics. Global teams can take advantage of our global enterprise license option available in most countries, and virtual reactor licenses can be served either on-premise or on the cloud, which opens the door to using either your own hardware or cloud resources or a combination of the two. We also offer engineering services for those of you with a one-off project, or if you have an urgent need, or if you'd like to gain the engineering benefits of modeling your system with Virtual Reactor prior to building out a team of your own to run the software. So contact us again if you want to learn more about that. The easiest way to get started is usually with attending a training class. Our next class is coming up in about a week and a half, and I'll have a little bit more information on that in a few slides. Training can be combined with project work and licensing in what we call our Quick Start program, which is intended to get you up and running as quickly as possible. We run the first few models for you with our engineering services team, and then we hand the models over to you, train you on the software, and provide the software licensing. This allows you to build out your own in-house capabilities with models that are already up and running. Finally, we work with people in a variety of custom ways through various R&D partnerships, whether it's fluidization research, developing new numerical models, technology development, or other things. R&D partnerships can be direct with us or collaborative with some of our other strategic partners listed here on this slide. So talk to us if you have interest in that. We do have some upcoming events that we wanted to highlight. As I mentioned, training class is a great way to learn about Barracuda and get started with it. Our next web-based training class is from August 22nd through the 26th, and this will mix videos, online tutorials, and once-a-day virtual meetings with our support team engineers to help you learn about Barracuda in a really efficient way. In September, CPFD will be presenting at the World Congress on Particle Technology, which will be in Madrid, Spain. And if you'll be attending that conference, please make sure to find us and check out our presentation. In October, our technology partner, PSRI, is having their fluidization seminar in Chicago. This seminar covers a wealth of information that PSRI has developed and organized over many years. And finally, in November, CPFD will be sponsoring and presenting at ERTC, which is the European Refining Technology Conference in Berlin, Germany. So if you're attending that conference, we hope to see you there and encourage you to attend our presentation there as well. Check out our events calendar for more details on these and many other upcoming events. And if you have an upcoming event that you'd like us to put on our calendar, please send us information for that. I think at this point we are ready to answer some questions. So if anyone has any more, please put those in. I see a couple have come in. One question that's come in is, how do metered licensing, or how do metered licenses work? What is the difference between a regular license and a metered license?
Okay, yeah. So regular licenses, they'll limit the number of simulations you can run simultaneously, but they typically have a long time period before they expire. So if you have 2 regular licenses for a year, you can run 2 simulations at the same time, but all year long. But if you purchase a metered license, you purchase a certain number of hours, which is typically less than a year's time. And then you can run as many simulations as you want at the same time. And each simulation will draw down that meter for the amount of time that the simulation is running. So this can make metered licensing a great solution for customers or people who want to run many simulations in a really short period of time. And then afterwards, you may not need the multiple regular licenses throughout the year. So
okay, great.
That's kind of when we recommend adding a metered license if you just need like a burst.
Yeah, it's an interesting new possibility that with RLM Cloud we're able to do that. Okay, I see another question has come in. It says, is PS the same for all particles, or can it be different for particles versus droplets and particle-droplet pairs? So I think what this one's referring to is the stress model. There's a term called PS that is set for the stress model. Do you want to take that one?
Well, I'm not quite sure on that one. So
okay,
why don't you take
I can take that one. Yeah. Currently, the stress model in Barracuda is a global model, and basically you have to set it for everything. And so, yeah, it is not different for particles or droplets in the current release of Barracuda. It's a global setting that applies to everything. So, yeah, be aware of that. If a different stress PS value, the pressure on the solids value, would be appropriate, then you'll have to adjust that, and it will affect all of the Lagrangian entities in the model. Okay, I see one more question, and so we'll take that one, and then if there are no more, we'll wrap it up here. The question is, I took a Barracuda training class 7 years ago, and a lot has changed since then. Can I attend training again?
Yes, the answer, of course, is yes. We'll be happy to have you join a training class again. A lot has changed, and it really is great to go through the problems again and look at the GUI and see all of our videos and recommendations. And it's very, very common for existing users to join our new web-based training classes for a refresher and to learn more about new capabilities. And our new training class format, it's quite efficient in the sense that you don't need to travel anymore. And most people get through the material in about 3 hours per day for 4 days during the week. And the classes are run by our engineers and me a lot of times.
You're an engineer.
Yes, I'm an engineer. and our support team, our training team. And we use Barracuda every day. And so you can ask us questions during those virtual meetings, and then we can assist you right then. So just email us at training@cpfd-software.com if you'd like to sign up or you'd like to join our training class this month, or we have another one a little bit later in the fall. I think it's in September.
I think so. I think we've been trying to schedule them, I think roughly every 6 weeks-ish.
I think so.
I would have to look at the calendar to be sure. Yeah. Okay, I see one more question's come in. For condensation, what would be the droplet size that is formed? Really, the particle size or the droplet size is determined by the mass of liquid on the particle and the density of that liquid material. And so basically, if condensation was to deposit a certain mass of the material from the vapor phase back onto the liquid phase, the size of the particle would just increase based on the liquid density and the new mass of the particle. So there's nothing too special about that, kind of similar to how solid particles have been treated in the past. If they grow from chemistry, for example, the overall particle size is based on material density that's composing the particle. Okay, well, I think that is all of our questions, and so if anyone thinks of any other questions after the webinar, of course, please feel free to email our support team, and we will be happy to discuss anything further. So thank you all for joining us today, and thank you, Rosemary, for presenting this information about the 22 release. Thank you all. We will close the webinar at this point.